In a sailing race, Josie travelled the path as shown in the diagram. Find the distance between the two buoys to the nearest tenth of a kilometre and the bearing on which she must sail to return to buoy 1. Well, first things first here, I'm going to stick a north line just here. And if this is 50 degrees, this would be 130 degrees. Then if we look around a whole circle, we know there's 360. This is already 230, so we need another 130 degrees here, which means if I put a north line here, that this is 50 degrees. So, if I can calculate this angle just here, I'll be able to get the bearing, and we also want this here, so I'm going to call this X and I'm going to call the angle Y. Now, let's look at the information we've got. Well, we want to find X. We have two sides and an included angle. So if I call this A, this would be A, and I can call this one B and C. And if I do, let's just get my blue pen back. If I do A, B, C, and A, B, C, we're trying to find this one, and we know this one, and this one, and that tells me that I'm using the cosine rule. So a squared is equal to b squared plus c squared minus 2bc cos a. So that gives me x squared is 3.4 squared plus 5.7 squared, take away 2 times 3.4 times 5.7 times the cosine of 100 degrees. So we can calculate x and we can use an e-activity to do that. So I'm on the cosine rule e-activity. What am I trying to work out? I'm trying to work out a. So let's clear that. Now my b here is 3.4. And my c is 5.7. And my angle is 100. So that gives me 7 point... Well, I was supposed to give it to one decimal place, wasn't I? So 7.1. And I might make a note of a couple more decimal places because I'm going to need this one. I'm actually going to make that note off the side of the page. You won't actually see it going down, but 7.126051. Okay. So we now know this side. We know that this is 7.1 kilometers. I now want y so I can work out the bearing. Now what I'm going to do is do some relabeling. So let's just get rid of these labels, because I now, since I'm finding this one, I'd like that to be A, which means this one is A, and then I could call this one B and this one B. And if we do the table for this, so A, B, C, A, B, C, this is Y, and this is 3.4. The B is 100, and little b is the 7.126051. And I know a complete row, which means I can use the sine rule. So I can say that A over sine A is equal to B over sine B, and substitute in. So that's going to be 3.4 over sine Y is equal to 7.126051 over the sine of 100. And then we can use an E activity to find y. This time it's the sine rule that we're using. So, in actual fact, it's stored that number, but it's stored it in A. And I could just copy it and paste it into B. And then A, we actually know is 3.4. The angle A is what we're trying to find. And angle B is 100. And solve. And we get 151.97. That doesn't seem like the right angle, does it? If we look at this one here. So that certainly hasn't worked in this particular case for us. And there's no way that that could actually fit in a triangle. We've already got B as 100. So what do we do in this sort of situation? Well, we don't panic about it. We're just going to go back to here, and we're going to solve, and fraction equals fraction. And what have we got? So we've got 3.4 over sine, nope, didn't go over sine, well it's y, but I'm going to use x. And this one should still be pasteable, over sine 100. And I'm going to use the given that line so that I don't get that complicated looking answer that we talked about before. So math 3 is a given. And this is an acute angle, so I'm just going to look for answers. And so that's 90. Let's see if we can find an answer in that, which many brackets there. And it's going to find 28.03. So, what about my bearing? Well, my bearing is clockwise from north. We know all the way around is 360, so my bearing is going to be 360. Take away 28. I'm going to give it to the nearest whole number anyway. And take away the 50 from here. So 360, take away 28, take away 50, and that's 282 degrees.